Now that we learned about the likelihood function, the thing that we're trying to maximize, let's talk about a gradient ascent algorithm that tries to make it as large as possible. In this section, we're going to go through a little bit of math, a little bit of detail, but in the end, the gradient ascent algorithm for learning a logistic regression classifier is going to be extremely simple and extremely intuitive. So even if kind of the likelihood function is a little fuzzy for you and the gradient stuff is not totally clear, but in the end, the algorithm they're going to implement is going to be something that only requires a few lines of code, and in fact, you'll be able to do that extremely easily. Good. So we've defined the model we want to fit, logistic regression model. We talked about the quality metric, the likelihood function. Now we're going to define the gradient descent algorithm, which is our machine learning algorithm that tries to make the likelihood function as large as possible and find our famous W hat that fits our data really well. Now we can go back to this picture that we've seen a few times where we have multiple lines, they have a likelihood function, and we're trying to find the one that has best likelihood. This line here with W0 equals 1, W1 equals 0.5, and W2 equals minus 1.5. And we now know that the likelihood function is exactly this function up here, the product over my data points of the probability of the true label given the input sentence that we have. And so our goal is to take this L and optimize it with gradient ascent. That's what we're going to go after right now. So as a quick review, we have our function, likelihood function, and we want to find the parameter values that take this likelihood function. So this is the W0, W1, W2, which is a function of 3 parameters in this little example over here. And we're trying to find the maximum over all possible parameters, W0, W1, and W2. And there's infinitely many of those. So if you try to enumerate, it would be impossible to try them all. But gradient descent is kind of this magically simple but wonderful algorithm where you start from some point over here in the parameter space, which might be the weight for alpha is 0, the weight for awesome is minus 6, and you slowly climb up the hill in order to find the optimum, the top of the hill here, which is going to be our famous W hat. They might say that the weight for awesome is probably going to be a positive number, so maybe somewhere like this, say 0.5, and the weight for awful is maybe minus 1. Now in this plot I've only shown 2 of the coordinates, W1 and W2. I didn't show W0 because it's really hard to plot in 4-dimensional space. 4 dimensions. So I'm just showing you 3 out of those 4 dimensions. Now let's discuss the gradient ascent algorithm to go ahead and do that.